Thanks a lot. I'm a huge Star Trek fan, and I'm sure there'll still be Linux and ARM on the Enterprise when we get to that. Okay, well, I'm really glad to be here today. This is actually a treat for me as well, because in addition to my career at Qualcomm, I've been at Qualcomm a long time, since 1991, working on wireless and cellular. I'm also an experimenter, and I love to work with Linux, and I've used the various boards and the community boards and been part of that too. So that'll weave that into some of the talk here. First, just kind of a little look back at the mobile industry, and the way we think of it is mobile. The modern version of what we call mobile business or mobile technology kind of started about 30 years ago, when we had analog cellular, when cell phones and portable wireless battery-powered devices started to be very popular and reach large volumes used by consumers, kind of changing your life, the ability to communicate. And the focus for many years was connecting people. So you could talk to someone, you could send a text message to someone, you could send email to someone, and then later it got to be sharing pictures and videos, but it was connecting people. That was like a big thing. That's what the operators were offering packages that you would buy so you could talk to people. And that was the main thrust of it. Going forward from now on, we're going to be connecting their worlds. We're going to be connecting. We're not just going to be talking or texting. We're going to be sharing experiences, immersive experiences that are real time, that are very rich, that are video, audio, sensors, data, augmented reality, those types of things on a massive scale between people, between things, machines. So we're basically going from connecting people to connecting everything. So keep that theme in mind. Another theme that's really happening a lot is devices and machines are becoming much more intelligent. And we'll talk a little bit about machine learning, how we define that, how we think of it, what the impact of that's going to be. Obviously, there's enormous interest in almost all fields now about this topic. We're really seeing it in the mobile business, where we're placing intelligence in all kinds of devices in new ways. And I'm going to talk a little bit about a very interesting point of this, which is where the processing is done. Where, is it done in the device? Is it done in the cloud? There's pros and cons to both of those, and we want to be able to support them in kind of some interesting ways. As I mentioned, I've always enjoyed being an experimenter, and the Dragon board development kits, the 410C and I'll mention a little bit about the newer ones coming out, have really been a great project for us. And we've worked with Linaro with 96 boards, and I think I have a picture of it here. It's so exciting, all the progress that's been made. When we first announced this board, I was like, I got to get one of these. I want to get it as soon as I can get it. And I got the board, and because I've been using Raspberry Pi for a couple of things, which was great. Actually, I like that product a lot. I have a bunch of them. I wanted to use this, and I first turned it on. I had some problem, and a whole bunch of people at Qualcomm said, oh, I can help you, I can help you, I can help you. And I said, thank you, but I want to try and do it through the external resources, the forum, the 96 boards, Linaro, get the code, and see if I can bring up the board, even if I'm not don't have direct access to the developer. And the first time it was hard. There was code you had to combine, and some things didn't work quite right. But geez, it's gotten so much better, and now it's just a piece of cake. And it's so exciting. You can just order these boards from Arrow and others. There's all kinds of mezzanine boards for cameras and audio and other things. So it's just been really exciting. Now the 410C is a pretty powerful processor, but it's not really on par with what the state of the art is. And so, I'm going to mention this too. It's finding its way into some really great use cases. And this is a picture of a FIRST robot from the FIRST robotics competition. Maybe you're familiar with it. Started by Dean Kamen 20-some years ago. Very popular around the world. There's thousands of teams, hundreds of thousands of students, and they're now making use of this board for the first global robot, and we're real happy about that. So it's having a real positive impact for kids in STEM and education purpose. But we're looking ahead to the next generation. Now, this isn't a place where we can actually make the official formal launch, and I think some of you know about this anyway, but we are coming out with a follow-on to the 410C, the 820C. C is for community. And that's a very, very powerful chip, so we're very excited about that. It's really the same processor that you find in modern, fairly recent high-end smartphones like the Galaxy and the LG and the HTCs, those kinds of devices. It's got a lot of capability, a lot of devices on the chip in addition to the CPU, the GPU, the DSP, and there's all kinds of connectivity subsystem, and there's a lot of capability with that. So, and as an example, the same core, we have another version called the 820A, A is for automotive, that we're going to be using for automotive applications. So that's just an indicator that it's a very high performance part that we're using for many things. Okay, let's talk a little bit about machine learning and how that fits in with this. This is a quote from IDC. I found it a little surprising, actually, but I think the main thrust of it is actually correct. That in the past, most software developers in most instances, are not incorporating what we call cognitive capabilities into their applications, and that is expected to dramatically grow. Now, whether it goes from 1% to 50% in 1 year or a few more months, I don't know. But I think the general thrust of this is exactly right, and I'll define specifically what we mean by this. So what is AI? These are some quotes that I got from taking Andrew Ng's course. If you haven't heard about that on Coursera, it's absolutely excellent. And I did that myself recently. Field of study that gives computers the ability to learn without being explicitly programmed, or kind of more precisely, a program that learns from experience E with respect to some class of task T and performance measure P. And the deal is, if the performance on the task T improves with experience measurably, then we call that machine learning. It's not like someone changed the code or changed the algorithm. They simply provided it with more data and ran the machine more times, and given that it improved its performance measurably, then we consider that in the class of machine learning or artificial intelligence. And that is what's really, really, really hot right now. And there's so many use cases. So computer vision, and I'll show you a video of that that we're using for automotive. I saw a demonstration yesterday at Qualcomm of the ability of a phone to recognize an animal, not just an animal, but whether it was a dog or cat, but not just that, but what species of dog it was. And they did all of that processing, all that inference on the device, so it can give you a very fast answer and also be very private about what you've pointed it at. It doesn't have to leave the device. So that's computer vision. That's kind of a traditional application of this. Language, translation, and speech to text and so forth. Cybersecurity to detect not just a scan of the memory to find a signature of a piece of malware, but actually detect by observing the behavior of a device that it's behaving in a strange way compared to the norm, and flag that. Autonomous vehicles, robotics, of course, huge applications there. Performance optimization. An example of that is inside our flagship products, the issues of power management, for example, are very complex. There's lots of subsystems. You want them to go to sleep as much as possible, but you don't want them to not be available when they're needed. So there's a very complex power management. In the past, that's kind of a heuristic algorithm with a bunch of conditionals. Now we can train it with machine learning and get much better performance. Data management, of course. So that's just an example of the ever-increasing use cases. In fact, it's displacing traditional signal processing in many instances now, in modem design and equalizers and receivers. So it's just an amazing thing. Now let's talk a little bit about on-the-device intelligence and where processing is done and where this machine learning and other types of things are done. There are key benefits to doing processing on the device. If you do it on the device, you can be much more efficient in your use of connectivity and bandwidth. It can potentially be more reliable if you're inside, if you're in an area where your connection's coming and going. It can be more secure, more private to you, and low latency. Now we're going to talk about that because with 5G, we're going to lower the latency. So that's going to move the boundaries of some of these things. This is just a back of the envelope example. In this example, you've got an application where you want to know how many seats are on a bus, how many empty seats there are. So maybe you have some kind of app, and when the bus is coming up, you know if it's full or empty, or if you're the fleet operator, you can kind of track that. So how are you going to do that? Well, one way is to put a camera in the bus that looks at all the seats. Okay, it's going to take a picture every few seconds. It's going to run some algorithm, and it's going to tell you the answer. Now, where are you going to do that? Are you going to do that algorithm on the bus or in the cloud? If you do it in the cloud, then the processing on the bus is very simple. It's just a camera, it sends pictures. But now you've got to send the pictures over the radio every few seconds, night and day for hours and hours on end, and you incur a cost of bandwidth. And you can multiply that out based on some data plan, and it can be, for 20 bus fleet, it can be very expensive per day. If instead you can put that processing on the bus, and it can do the computer vision and recognize the number of seats that are occupied, then instead of sending like raw video frames back, it can send the answer back, and you can save a huge amount of cost. So that's an example of why it can be very powerful and beneficial to put processing in the device. Now, I should say there are instances where the other way is also advantage too. Those are instances where you want to have extreme processing that goes beyond what you can fit. And in that case, you want to have a low latency, a link like a 5G, and we'll talk about that in a minute. Okay, to facilitate what I've just described to you, we've introduced something that we call the Snapdragon Neural Processing Engine. Internally, we know it as Snappy, but externally, it's the SNPE. And it allows, it's a framework that allows these type of networks to be run really efficiently on the Snapdragon. And underneath it, it can make use of the CPU, the GPU, or the DSP, depending on which is optimal for that network. Okay, I'm going to give you an example. You're going to see a video here. And this video is not a simulation. I mean, it's a video that ran on an actual Snapdragon device. So think of it as something that ran in real time on a mobile. It wasn't done offline or anything like that. And it's going to categorize what it sees in terms of pedestrian, tree, building, road, sidewalk, and it looks like this. And this is an example of categorization, and it can lead to, as an input into an algorithm that's going to do autonomous driving. Here in this case, it's putting bounding boxes around objects and categorizing them as pedestrian or vehicle, and that all runs on the device. Okay, and then there's the next one. This is one I'm personally very excited about. Is you're going to see another application of this for drones. Now, in this video, this is a clip from the CES show earlier this year, and you'll see our CEO, Steve, and Sarah, one of the lead engineers on the project. They're going to show you the drones flying around. Now, keep in mind, when you watch these drones flying around, they're navigating with great precision indoors without any GPS. They're using only the camera. And while they're doing that, at the same time they're doing all the flight control, they're also doing this categorization and machine learning. And they're doing it all on the device on a board that only weighs 15 grams. And this is a case where we rarely talk about the mass of the processor, but in this case, the mass really matters because it reduces the weight and therefore increases the flight time and a smaller battery and so forth.
Now comes the next big task. The drones do not know ahead of time what they'll encounter in the room. So they're going to have to identify objects that come into view in real time as they navigate the course.
We're seeing some streaming video come in from the drones. Can you tell us what's going on?
So this is live video from the rear drone. As you can see, it's identifying objects that come into view using its camera and an on-device machine learning model. That model is running in the Snapdragon neural processing engine concurrently with Snapdragon Navigator as it moves around the course.
So Sarah, they look to be speeding up. Can you tell us a little bit more?
I sure can. So we really wanted to push things even further here. We can make this happen using the Snapdragon Navigator software. It offers state-of-the-art real-time flight control with advanced safety and autonomous features. Real-time flight control is important. It means the drones can take desired speed and direction and translate them into motor commands. And GPS doesn't work well for positioning indoors.
Okay, that was really fun. We actually have so that was indoor. We have outdoors in San Diego a flight center that's really close, 2 miles from a military airport, and we got special permission to operate in concert with connectivity to the air traffic control. And we're doing tests of this using cellular as the connection method. And it's really working great. In fact, we published a paper on all the issues there, if you're interested in that. OK, now in the last part of this talk, I'm going to talk about 5G, which is the next generation of cellular technology that's coming fast. It's a really big project for us and others. We've been working on it for years already. And you're going to start to see this commercially launched around the 2019 timeframe. There's going to be some precursor activities already next year. There'll be some stuff at the Olympics in Korea, a couple other things. Verizon's doing some things. But the mainstream is going to arrive around 2019, which, by the way, is a year acceleration. It used to be 2020. And it's going to be, we call it a unifying connectivity fabric, because it's going to combine high speed, in other words, just making your 4G faster, so you can do all the things you do today at higher speed. You can pull in more videos, your web access will be faster, all those things will just be faster. Same service, but faster. But also new services that come about with very low latency and very high reliability, and we'll talk a little bit about that. And mission-critical services that are well-suited for like public safety or smart cities or things that need to be very reliable. And then massive Internet of Things, where we have tiny devices that are very low cost in huge numbers, as many as 100,000 in a sector of a base station. And still the access technology will allow that to be efficient and low power. So all of those together, unified, is what we think of when we think of 5G. And we talk about cutting every cord. So again, this gets back to the topic we had earlier, which is where you can do processing. If you think about a traditional desktop PC sitting on your desk, and it's got a monitor, and there's a little cable that goes between the monitor and the box, and then there's like an Ethernet or Wi-Fi that comes out the box to go to the internet. Why is it that way? It's that way because we initially put the wireless interface where the network interface was. We didn't think to put the wireless interface where the monitor was plugged in, because if you cut that cable, if you cut the HDMI cable, then you need a gigabit link at low latency. So you didn't do that. You cut it, you put it on the other side. But we're bringing in a world now where we will have gigabit links of low latency at reasonable cost and mobile with large numbers of users. And so it is possible to make the interface at a different point in the architecture and realize some really interesting benefits. So that's what we're thinking about with 5G. We can use it for an interface into a residential unit. We can place the displays on different sides of the link. We can do wearables in different ways. We can put in machine learning in different ways. So in this kind of depiction, we're talking about XR, which is kind of a combination of augmented reality and virtual reality, what we call it extended reality. So if you put on goggles and you see only the display and the world is completely virtual, that's virtual reality. If you're holding up your phone and you're seeing you see what the real world is with some graphics on top, that's augmented reality. If you have glasses that can see the real world with the real light, like real glasses do, with augmentation on top of that, that's kind of mixed reality, or XR. You can think of companies like Magic Leap and a couple others. We think this is very important. This is potentially at long last, a new form factor that's going to become popular. Now, not today because they're still big and expensive, but they're making huge strides. And remember, 5G starts around roughly 2020 and goes for 15 years, let's say, to 2035. So in the middle of that span, the PC is 50 years old, the smartphone is like 30 years old, and the question is that little rectangle going to be the form factor we have in 2025? I think it'll still be around, but you're going to see a lot more of this kind of concept. Okay, IoT. So this graphic is just trying to depict that there's lots of dots. And what we mean by that is anything that consumes a resource or can be measured or has any kind of parameter on it can now be connected at low cost. The battery can last many years without replacement. It can have a very deep link budget, so you can put it downstairs. And the network can actually handle the access of a huge number of terminals because we've very carefully designed the access protocols so that they can be efficient and you can get the data from your sensors and not have to have a large annual or monthly cost to offer that connectivity. So that with the machine learning and the cloud is really going to increase our ability to utilize resources, transportation resources, emergency responder resources, building infrastructure, power, energy, all those things are going to be more efficiently used because of what this is going to enable. And in fact, I should mention in the standards process for 5G, traditionally, 4G, 3G, 2G were created by the telecom companies, and that's still the case. But there are far more companies participating. There's like 1,000 companies participating now from all different industries in the 5G process more than ever. So those inputs are being taken in to design these use cases. It's no longer just a 3-minute voice call. It's completely moved beyond that. Okay, so I kind of mentioned this high reliability, low latency, high availability. And let me just take a second to talk about the low latency part. On today's 4G networks, we can get down to on the order of 10 milliseconds, and I'm talking about the radio part. With 5G, we'll be able to get to a millisecond, or in some cases even less than a millisecond. And that will allow, again, processing to be done in a different way. It will allow real-time applications, control applications. It will allow AR and VR and with new architectures where you can have tremendous processing power. However, this is important for this audience too to just keep in mind. It's not enough just to take the latency of the radio down to a millisecond. In many cases, the entity that you're interacting with, the server, if it's a game server or a VR, or if it's something related to a mission-critical application, it can't just be 100 milliseconds away in the cloud. It has to be also relatively close, or what we call the edge. So this brings in the notion of edge computing. And to give you an example, 2 weeks ago, 2-3 weeks ago, I was up here at the Mobile World Congress, and at the Verizon booth, I saw what I thought was a really cool demo. They had a drone. It wasn't a nice, well, I shouldn't say nice. It was not an expensive drone. It was a very low cost, $18, tiny little drone about this size. And the only thing this drone had was a camera that could send back its pictures. And they were flying it around, and they had a balloon, a red balloon, in this net. And this little tiny drone would send its video back, and they had edge processing, and it would process the video, search for the balloon, and send back control, and allowed this little tiny drone, which only cost $18, to chase the balloon around indoors and be precise. But they had to have the processing at low latency. They would then switch it to a distant, they had a AWS set up that was far away, it was like 50 milliseconds away. And once they switched to that, the control loop was not possible to maintain anymore. So that was an example that you need the high performance radio link and the network capability of processing that's relatively proximate together. Then that unlocks this whole new world of these types of applications. So I just wanted to point that out. Okay, I think I'm almost at the end here. Oh, that's the end. Okay, so that's kind of an overview of where we're going with 5G, where we're going with machine learning. We love the Linaro and the community. I'm on the support forums myself with the 410C, and we're looking forward to the 820C, and we're really happy to be part of all this. Thank you very much.